Hey, hi all. Hi all. In this video, we'll discuss regarding the normalization. So, normalization is just like process. Okay, how to store the data in proper way. How to store the data in proper way. Where we are storing in the database as form of the table, right? So, just to process normalization is just a process to correct the table structure. Okay, so means how we are going to organize the data. Okay, to reduce the duplicate data and improve the data integrity. Okay, while storing the data, we need to check. Okay, we need to avoid duplication of the data, and we also maintain the data integrity. Okay, so simply we need to avoid data anomalies. So anomalies like when happen can be while inserting the data, while updating the data, while deleting the data. Anomalies simply like issues. What kind of issues we are facing? Okay, like inserting the data, unable to insert the data due to other required data missing. Update, there is a high possibility and risk having inconsistency data after the update. Delete, unintended loss of unintended loss of data when deleting the record. Okay, what are these statements? Okay, by end of this session, you will come to know. Okay, what are these problems? Okay, how we are going to overcome. Okay, now come here. If you take one department, we'll get one column department ID, department name. If you take employee, okay, this is a take. This if you take employee, employee ID available, right? So employee name, mobile number. See here, I just kept as a multi-valued attribute. Means one employee can have multiple mobile numbers, right? Okay. And if you come here, employee address. How employee attribute? It's not like a single value, right? There there should be some house number, city, state, okay, some town number, sorry, town name and pin code, everything will be available, right, as employee address. So this is composite attribute. Okay, so what is composite attribute? That composite attributes can contain multiple, okay, columns. Okay. Multi-valued attribute means one column, okay, having the multiple values. Okay, come down, we will see how we can handle this multi-value and composite attribute. So we need to follow some rules, right? While storing the data, okay, as form of table in the database, right? Okay. Now, see, we need to follow normalization techniques. The first normalization technique is what we have to do. Cannot be composite attribute while storing the data into the table. Okay, cannot be composite attributes. See how this is the one I'm referring. So this is a composite attribute, right? Employee address. All the details like house number, city, state, pin code. We cannot store employee address. Okay, that is the first normalization from the first part. Second, cannot be multi-value. See, here is the multiple value, right? See, as I told, right? Here, multi-value. So, a person or one employee having multiple mobile numbers means, okay, even though employee having, we cannot store all together as a single value. Okay, we cannot store like that. Okay, that's fine. So, how we can store? Cannot be composite attributes. That's fine. We'll check how we can divide this data down the line. cannot be multi-valued. Okay, fine. Then how we can store? How should be data? Means always like this. See, only one value, one value, one value, name, one value, value, one value, like this. It should be. So here I tell you, each field should have only one value, means atomic. Okay. So each field means this one, right? This is the field. Okay. If you go to Excel, okay, Excel, rows, right? The columns. What is cell? See this cell, right? Means field, one field. Okay, like so each field means this is the one should have only one value. Okay, and column should have unique name. See, column should have unique name. Contains same domain data. Contains same domain data. Means same data type. Means here employee ID I can keep one. Next I want to keep a. No, we cannot keep like this. Okay, in column, right? Each column should have unique name. Employee ID, employee name, mobile number, employee address. The column names are fine, but how we store that is wrong. Okay, how we can rectify down the line we'll see. Okay, how should be? Say each field should have only one value, and the column should have unique name, and whatever the values particular that column should have same data type. Same data type. Data type means type of the data. Like that could be text. Text is one type of data. Like numbers 1, 3, 4, 5, like this. This is one type. This is text means character or varchar data type. We'll learn all these data type. Okay. This one is number data type, right? This one is number. Okay. So if this one is number data type column means everything should be numbers only. You cannot keep one field as a like one, another field as a way, another field is like some XX. We cannot keep. That's the meaning. Same domain means same data. No duplicate rows should be there. We always try to avoid duplicates. Okay. If duplicates come, how we can handle, we will see. Okay. Now, so we cannot store multi-valued. We cannot store composite attributes. Then how we can store? Okay. The ways. Okay. Let's see how we can see the same data. I modified like this. See, one Nelson, two see mobile numbers with comma separated. Okay, but as per first normalization form, we cannot keep as a multi-value, right? Then how we can divide? See, one Nelson, the first mobile number. See, here I'm keeping. Okay, now here this one, second mobile number. How we are keeping? See, in the second row, one Nelson. This is another mobile. Means I'm maintaining a separate record. Okay, but this for this one, right? Address is same, right? See, this composite attribute. How I'm representing. See now separate column. First one is house number, second one is city, third one is state, last one is pin code. So I'm dividing as each column. See, so this mobile number, right? Two mobile numbers. So I created the two rows for each row. This address is same, right? Address is same. Only mobile number is different, right? So this entire data is duplicating as a second, right? First is one fine, but second time, right? Entire these values are duplicating. We will see how we can avoid. Okay. Now, the what is the first normalization form? Telling cannot be multi-valued. Yes. No, we don't have multi-value. See, we divided. Cannot be composite. Okay. Cannot be composite attribute. Okay. See, now I divided here. Clear, right? Now, another way of doing. See here also, see here, three mobile. See, the same jar. Okay, three records. Okay, but address is same, right? See, this is duplicate, entire duplicating the data. How we can avoid? We will see. But if you compare with entire row, if compare with this row and this row, not a duplicate. But only few values are coming multiple times. Okay, so the same entire record set, right? Coming multiple times. But if you compare with entire record, all column, but this is okay, then this is not a duplicate. Okay, now another way of doing. Okay, here for only mobile first, right? So what I can do, I can maintain, right? Instead of doing mobile number, instead of converting into the two columns, sorry, instead of converting into two rows, okay, what I can do, this one I will consider as a mobile number one, okay, this one I will consider as mobile number two, okay, and if you have three mobile numbers, this one I will consider as mobile number three. Okay, here see how I divided mobile number one, mobile number two, mobile number three. So here coming the three records only, but columns are three columns for only maintain the mobile. But here only one column, but records are increased. Okay, that is the difference. But here is the problem is here is three mobile numbers. Okay, what if we have seven mobile numbers? I cannot create seven columns, right? I cannot create seven columns. It's very difficult. Okay, first, okay, approach whatever we are taking, right? This is satisfying. First normalization form means cannot be composite. Yes, right. No composite. Cannot be multi-valued. Yes, you don't have multi-values. Values are divided. Okay, this is first value, this is second value. What we are doing, we are converting that one into a separate row. Okay, if you compare with entire row, okay, just because of mobile number difference, two records are different, cannot be duplicate. But if you compare with only these columns, house number, city, state, pin code, then these two records are duplicate. Okay, then last three records are duplicate. But how we can consider the duplicate means it's based on the requirement. How you are checking duplicate. Okay, if you compare with entire records, there is no duplicates. Okay, no duplicates. Bro, should be. Okay, now come to second normalization. Before going to second normalization, see here we need to identify primary key also in the first normalization. So here employee ID, okay, employee ID is primary key. Here employee ID is primary key. Okay, so primary keys, right? Primary key, okay, shouldn't be a null. Sorry, shouldn't be a duplicate. Okay, shouldn't be a null and shouldn't be a duplicate. Okay, so now here you see here we have still have duplicates, right? 33311 it is coming. Okay, then we need to rectify this issue also. But we have to identify the primary key. Here the primary key is employee ID. Okay, let's go to second normalization. Okay, see in the second normalization form, right? Eliminate partial dependency. Eliminate partial dependency. Okay, candidate key to build the relation and first normalization should be satisfied. The first normalization form, right? Whatever the okay points we need to consider to fulfill the first normalization form, we have to do. Then we have to maintain no partial dependency in the relations. Okay, let's see what is this one. See, if you compare with above data only, The first see, 1, 2, 3. 1 is Nelson, 2 is Alex, 3 is John, right? See here, come to here. Employee, I'm segregating the data. Segregating the, okay. Now I'm taking this one as a separate table. Employee ID, employee name. 1, 2, 3. 1 is Nelson, second is Alex, third is John. Then this is like EMP table. Also. Now, for whatever this one, right? Address attribute. See how I'm dividing employee address. See, for this employee, okay, commonly see no partial dependency in the relation. Okay, that's right. We cannot keep partial dependency like how we are keeping partial dependency. See this for this address. Okay, I give we have like dependency. Okay, these things we are going to avoid. Okay, but before that, see candidate key to build the relation. Okay, before divide this data, we need to identify what is the candidate key. Here is the employee ID, right? So in both tables, right? In employee ID should be available in the address also. Then only we can come, right? So so and so Nelson. What is employee ID? One. If you come to here, one. What is Nelson address? 25 Hyderabad, AP, some pin code. Same thing. What is the Alex address? See, Alex address. What is employee ID Alex? Two. If you come to here, two, you'll get it. So this is the relation. Employee ID is the relation for the two tables. Like that, we are dividing the data. Okay. So now what we are doing, maintaining one column as a common. Okay. Then we are just removing partial dependency. We are just removing all this data and we are keeping as separate table as employee address by maintaining the common column, the candidate column, that employee ID. So that here, see, there is no duplication here. How here is the two times came. Here is only one time, right? Here this record came three times. These values came three times. But here coming only two times only, right? Till we are able to find out, right? What is this Jan address means? See, it'll come here. What is Jan email ID? Three. Sorry, employee ID three. We'll take these three and we'll check respective record. So that we'll get the address. Now, again, mobile numbers also I'm maintaining separate. See, come here. Here, employee ID, mobile number. I want to find out Jan mobile number. See, what is Jan employee ID? 3. Here, see, we come to here. 333 means these three mobile numbers related to job. Okay, or else go back. If you take mobile number, what is this mobile number? We don't know. Who's this mobile number? We don't know. But employee ID we have one. Okay, we want to find out name means take this employee ID one, then search here one, then who is the name employee of the number one Nelson. Okay, so both ways we can get it. See, so in this second normalization form, we are eliminating partial dependency. Okay, so instead of keeping the all data in the one table, what we are doing, we are normalizing the data. So normalizing the data means the way we are storing the data. Okay, to identify easily, to avoid the duplicates, everything. See, and also we need to maintain relation between the table to find out. Okay, whenever you want to information with respect to this employee, like address or phone numbers, easily we can how we can track it. Okay, just because we are maintaining one common column. Okay, so instead of maintaining all data in one table, now we are storing the three tables. One, two, employee like mobile. Okay, so we need to follow the same means. So based on the data, we need to check. Okay, how many normalization forms we can apply. The first normalization form we applied whatever the data, right? If you are able to see, that is good. If you feel, then stop it here only. You don't want to normalize more till, see, I'm feeling these are the duplicates, right? I don't want these duplicates, so I'm applied second normalize. So I removed the partial dependency and making separate table so that I'm avoiding the duplicates here. Okay, still we have here duplicates, that's okay, but somehow, okay, we eliminated all the duplicates in the two tables, and also we are not repeating some data. Okay, from if compare with here to here. Okay, if you come to one more example. Okay, we have seen employee id, employee name, salary, department id, department name, department location. So all are I maintaining one table. Okay, but see here, which one is duplicating? See here, two times. Okay, three times. Okay, if you have 1 crore records, okay, these kind of records will be available, right? So many, means the same department name, same department location, we have to keep on add. Okay, to avoid this one, what we can do, we can remove this partial dependency. We can create separate table. Okay, now see, employee id, employee name, salary, and department id I'm keeping here, and I'm creating department data separately, like department id, department name, department location. This is a table, this is department table, this is emp table. Okay, so instead of one table I created two tables, so that only one value only repeating. That's fine. Instead of repeating multiple columns data, okay, if repeat only one column data, that is fine. Okay, now see here, one, two, three times is repeated here, but here, see, only one time available. Okay, if you come to here, department number 20, what is exactly name is based on this one, right? The common column, this one. Take go 20 here. What is the department name? You can easily find out, right? Okay, for that, what we are going to use giants. Okay, everything we are going to learn. Seems these are like uh, theory concept, but these are very very important. Okay, but at the end of the course, right? Okay, you'll you'll come to know automatically what kind of normalizations, okay, concept, okay, we are using. First we are normalization form we applied till we have, okay, some problems, then we will apply second normalization form. Okay, still we have some problem, then you can apply third normalization form. Okay, so we have to feel this data is fine, this data is normalized, means normalized means it is available as a proper. Okay, now third normalization, what is this one? Eliminates, okay, transitive dependency. What does it mean? Okay, if you go to here, start to by attribute that form candidate key are prime attributes. Here, what is the prime attribute? This is the employee ID. And okay, rest attributes are non-primary attributes. Rest attributes means, see, employee name, salary. Here, department ID also prime attribute. Okay. Now, here see, house number, city, state, pin code. These are non-prime attributes. Okay. Prime attributes we use to link between the data. Here is the address data, here is the employee data, here is the phone number data. What is the prime attribute here? Employee ID, employee ID, employee ID. Non-prime attributes, okay, this one, maybe pin code, based on pin code, okay. For that same pin code, state, city, mostly same, okay. Some villages, mostly same, okay. But based on pin code, we can see state, city, but this is not a primary attribute. Primary attribute is only employee ID, okay. Now, eliminate transitive dependence. What does it mean? Before applying third normalization, form, we should have applied, okay, first and second normalization form. Then we should apply third normal, third normalization form. What does it mean? See, there should be no transitive dependency for non-primary attributes. Means non-primary attributes means I told right this one zip code. Okay. Based on zip code, we can find out country, city, but these are not a primary key attributes. Okay. So here see employee ID, some name, some city, country, zip code. So how we can normalize? Okay. Here still we have some dependency, right? Here, see there is a dependency. See these two records. Okay, there is some dependency. How we can cut it up? This non-primitive, okay, attributes dependency. See here, employee I'm taking, employee name and city I'm taking. So based on now, I'm maintaining common column as city, then country and zip code. So for some AP, some India, some zip code. It cannot be like same zip code for entire state. Okay, I took an example. Okay, now Karnataka, some Tamil Nadu, some different zip code. So I just eliminated, okay, dependency on the non-transitive, okay, like non-primary attributes. Okay. I will you understand. Okay, if you have any doubt, okay, please comment. Okay, please send out a mail. Okay, now I'm taking one more example here. Here, see the data: student ID, student name, subject code, subject name, address. Here is what is the candidate key? Here, this one. This is the primitive attribute. Non-primitive attributes, see subject code. But still, see based on subject code. Okay, see one SQL. Okay, two Snowflake. Okay, see based on this code, right? We have some dependency data. Okay? So what we can do? See, based on subject ID, see subject ID, subject code, both are same. Okay. Now I'm dividing student ID, student name, subject ID, some address, some student address. That's fine. But whatever the values, right? Subject name, I'm just separating out as separate table, like subject code and subject name. What is subject code? 1, 2, 3, 4. So that we can avoid duplicates. We don't want to repeat the same time. If you have subject ID 3, okay, what is subject means take 3 and come to here. Here is the Python. Take subject 1. What is subject 1? See, come here. Check. Yes, that's fine. So that we can avoid, okay, we can eliminate, we can transitive dependency. Okay. We have like Vice code normal form. This is nothing but just okay implementing the third normalization form. If there any still we have some issues, okay, means if you are able to see some duplicate data, some other issues, means we can apply. Okay. Now, why we need to divide? Why we need to divide the data into multiple tables? Why we need to do normalize the data? Means simple. See, this is a big schema problem. Means see, big schema means all the columns if we keep on one table, it's a very difficult to maintain. Okay, I will tell you the problem. See, what if we keep all the columns in one table as a denormalization? No. See, problem is here. See, okay, here what is department? 10, 20, okay, 20, 30, 20, 60. See, every time see some duplicates are there. Okay, with help of normalized form, okay, we can avoid, right? If you apply one of the, okay, normalization technique, we can avoid this one. Okay. And also, I'm entering some data like one employee came, 7. Okay. Some AA, some 5,000. Okay. Department, something 70. Okay. Some machine learning. Okay. Some other data. Okay. Now, I'm introducing only one department. I'm not hiring the person. Department is 80. Okay. Now, some AI. Here is ML, machine learning is artificial intelligence. That is separate department. Okay. Now I'm giving some name. Here see, here I have data to give, but here I'm just creating department. I'm not hiring. Once I create the department, then I can hire, right? So for these columns, right, I don't have any data. I don't have any data. This is nothing but insert anomaly. See, whatever we discussed, right, above, unable to insert the data due to other required data missing. Obviously, right? We have only one department on data only. Now we are just introducing one department. We don't have any employee. These columns, right? If you use as a big schema, this is the problem. We don't have any data here for these columns, employee name, salary, department. We have only department information. Okay, that is insert problem. What is deletion problem? So here, see, I want to delete. Okay, here is the Nelson record. I want to delete Nelson record only. Means I want to delete only this one employee, salary, and name only. But I cannot delete only these three columns. If I delete entirely unintended data also will delete. This data also will delete. Why? Because so as this is same record. Okay, that is a deletion problem. If you maintain all the columns into one table as a big schema. Okay, that is nothing but the second point. Sorry, third point. Delete unintended loss of data when deleting the record. Then what is the update? There is a high risk, right, having inconsistency data. Let's see what is that one. Sorry. Okay. Now I'm updating something like department FICO, right? This one I'm trying to update like finance, not FICO. I'm trying to update finance. Okay. Where and all I need to update? Here I need to update. Here I need to update. Here I need to update. Three areas I need to update. But I need to look right. Here is the only 6 record I'm able to see. What if we have 1 crore records? Everywhere I need to update, right? Okay. So we may miss to update. And also it is very difficult also. Okay. So to avoid these problems, whatever insert, update, deletion problem. Okay. Whatever anomalies means just a problem. Okay. Issues. To avoid this one, what we have to do? We have to normalize it data. Normalize means keeping the data into different table. Okay. And we have to maintain the common column between all the tables. Okay. So, sorry, so that, okay, we can join back whenever required, we can get the data. Okay. So for this video, this is the regarding the normalization concept. If you have any doubt, okay, just you can send out a mail, okay, which is available in the description. Okay, thank you.